This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the solutions, relevant concepts, and the scoring guidelines associated with some of the parts of our 2020 mock AP Calculus exam, Form BC, Question 2. My name is Steve Kokoska. I'm a recently retired professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Form BC Question 2 involves a particle moving in the plane. Its position is given by a vector-valued function, x of t, y of t, at time t, where t is measured in seconds, and x and y are twice differentiable functions, both measured in meters. We are given a symbolic expression for the derivative x prime of t, and we also have selected values of y prime of t given in the table. And in addition, we know that the position of the particle at time t equal 12 is 4 minus 3. In part E, a new function r is defined to be the distance between the particle and the origin at time t, and we need to find r prime of 12. The key concepts needed to solve this problem are the distance between 2 points in the plane and the chain rule. Well, we'll also use the power rule, but I'm going to focus on the chain rule. The distance formula is not really a calculus concept. It's probably first learned in geometry class, but it is used in a variety of applications in calculus. If p sub 1 and p sub 2 are 2 points in the plane, then the distance between these 2 points is given by this expression. Now, just a reminder that distance is a non-negative value, that this value is always only the positive square root. To solve this problem, we'll also need to use the chain rule. Now, I won't read through this entire statement with you, but this gives us a method to find the derivative of a composite function, capital F of x is equal to f of g of x. To find capital F prime of x, we start taking derivatives at the outside and work our way inside, so that capital F prime of x is little f prime of g of x times g prime of x. And here's the chain rule in Leibniz notation. The chain rule is a pretty important concept. It's tested often on the free response portion of the AP Calculus exam. So let's take a closer look at this idea. In words, this says the derivative of the composition of two functions is the product of the derivative of the outer function evaluated at the inner function and of the derivative of the inner function. Here's some other common notation to illustrate this rule. We often use an open circle to represent the composition of the functions f and g. And here, just another common way to indicate the derivative. And here's a step-by-step procedure for applying the chain rule. I find that this is helpful for students as they first learn to apply this rule. Now, the most important part, and perhaps the most difficult thing before applying the chain rule, is to correctly identify the outer and the inner functions, f of x and g of x. And this just takes practice. Once f and g are identified, then find f prime of x and g prime of x separately. And finally, put everything together and write the derivative of the composite function as f prime of g of x times g prime of x. And here is a kind of visualization of the chain rule. To find the derivative of a composite function, we take the derivative of the outer function evaluated at the inner function times the derivative of the inner function. Let's use these concepts to solve this problem. We're given in the problem that the position of the particle in the plane at time t is x of t, y of t. So we can use the formula for distance to find an expression for r of t. Next, we need to find r prime of t. we need to recognize that r of t is indeed a composition of functions. In fact, in some sense, we'll have to apply the chain rule twice here. Take the derivative of r, starting at the outside and working inside. The outermost function is the power function. So we start with 1/2 times x of t squared plus y of t squared raised to the 1/2 minus 1, or minus 1/2 power. That's the power rule. We take the derivative of the inner function, a sum, term by term. The derivative of x of t squared is 2 times x of t raised to the first power times the derivative of the inner function x of t, which is symbolically just x prime of t. And similarly for the derivative of y of t squared. A little simplification leaves us with this expression for r prime of t. Now we need to evaluate r prime of 12. So we need to find a value for this expression. The position of the particle at time t equal 12 is given as 4 minus 3. We have x of 12 is 4 and y of 12 is minus 3 as given in the statement of the problem. A function for the derivative x prime of t is also given. So we can evaluate this function at t equal 12 to find x prime of 12. And we can read y prime of 12 from the table. And finally, with a little simplification, we get 243 over 65. Here are the scoring guidelines for this problem. Part E was worth 3 points. The first point is for presenting a correct expression for r of t. And the second point is for presenting a correct expression for r prime of t. And the third point is for the answer. Here are some interpretations of these scoring guidelines to help understand how points are awarded in this type of a problem, and to help prepare for the next AP Calculus exam. There is no additional work necessary to earn the first point. That means that the student doesn't need to show the distance formula explicitly with the minus 0 terms in there. And if the student earns this first point, it's in the bank. That means they cannot lose it. If they go on to simplify incorrectly, for example as a function raised to an incorrect exponent, then they are not eligible for the second and third point. Since we didn't ask explicitly for an expression for r of t, some students will start this problem by writing an expression for the derivative r prime of t. Now, if it's correct, then the first 2 points are earned. If it's incorrect, then we really don't know where the student started, and so unfortunately the student earns 0 of the 3 points in this problem. The second point is earned simply for a correct derivative. And again, if the student earns this point, they cannot lose it later on. If there is a simplification error, then the student is not eligible for the third point. And finally, the answer must be our answer. And that sounds kind of funny, but it means that we're not reading with the student if they make an error above. And functions, as a reminder, must be evaluated. That means we need to see the values for x of 12, x prime of 12, y of 12, and y prime of 12. However, a final numerical answer does not need to be simplified. In Part F, we are asked to determine whether the particle is moving closer to or further from the origin at time t equal 12. And there's that classic AP Calculus phrase, justify your answer. The important idea here is how to determine if a function is increasing or decreasing. Now here's my working definition, I think that many of us use. It's a definition of a function increasing or decreasing on an interval I. Now, note that this definition is given in terms of an interval as we move left to right, and it does not involve the derivative of the function f. However, the derivative of f can indeed reveal where the function is increasing or decreasing. Here's the statement of this increasing-decreasing test. And you can justify this by considering a graph of a function along with several tangent lines. If f prime of x is greater than 0 on an interval, then f is increasing on that interval. And if f prime of x is less than 0 on an interval, then f is decreasing on that interval. Note that in this definition that many of us use, the concept of increasing or decreasing is defined on an interval. However, it is common in real-world applications and on the AP Calculus exam, especially in contextual problems, to ask about increasing or decreasing at a specific value. Now, in my opinion, in order to answer these questions, we simply use the ID test, but at a value, not over an interval. Therefore, to answer this question, we simply need to consider the sign of r prime of 12. Well, from part E, r prime of 12 is equal to 243 divided by 65. Since this value is greater than 0, the distance to the origin is increasing at time t equal 12. And therefore, the particle is moving away from the origin at time t equal 12. The scoring guidelines for this problem are pretty easy. 1 point for the answer with an appropriate reason. But often, we have to read student responses very carefully to decide whether or not they've earned that 1 point. Here are some interpretations of these guidelines. First, the student must be working with the function r prime of t to draw a conclusion. They cannot earn this point by appealing to a different function or functions. We have to be convinced that the student is working with t equal 12 seconds. If there is no evidence of this time, then the student does not earn the point. The student must commit to the answer increasing. That is, they cannot conclude that r prime of 12 is greater than 0 and stop. They must reach the correct conclusion. The student does not need to report a numerical value for r prime of 12. We didn't ask for one in this part of the problem. They can simply look at their result in part E and indicate that r prime of 12 is greater than 0. And then, of course, conclude that the distance is increasing. In this problem, we will allow the student to import an incorrect value from part E. But their answer must be consistent with that value. So, for example, if they found r prime of 12 to be minus 3 in part E, then they must conclude here that the distance is decreasing. And I often talk about the answer that is the line in the sand, the absolute minimum necessary in order to earn full credit. I might not like the presentation, but it has minimally answered the question. Here are 2 such examples. Each of these would earn the point. I hope this video gives you a good idea of how to solve these problems using the necessary AP Calculus concepts and a reasonable expectation of how they would be scored. We'll look at more parts of this free response question in the next video.